Hello everyone. So today we are going to start the topic redox reaction. So let's understand why this word redox. So just as you see, Ranbaxy word has come from two founders, that is Ranbir and Guru Baksh. Similarly, that the distribution of redox is there. It has come from reduction and oxidation. Okay, so before we proceed ahead, we must understand the difference between reduction and oxidation reaction, right? So to define redox reaction, we can say it's a reaction in which oxidation and reduction are happening simultaneously. Yes, friends, please take care of this thing, that whenever redox reaction is taking place, so reduction and oxidation both happens, and reduction and oxidation cannot happen individually. If reduction has taken place, it's understood that oxidation has also taken place, right? So let's understand the difference between reduction and oxidation. To put it very simply, oxidation is nothing but addition of oxygen, right? Or it can be also any electronegative element. Okay, by electronegative element I mean the elements which have got tendency to gain electron. Okay, now this can include fluorine, chlorine, bromine, iodine. Okay, it can include anything which is electronegative. So addition of oxygen or electronegative element is oxidation. For example, you see here carbon plus oxygen giving carbon dioxide. So this is a very good combustion reaction, and you see here carbon is oxidized because you see oxygen getting added to the carbon dioxide, carbon, right? Now the next thing is oxidation is also removal of addition of electronegative elements. So you see here in magnesium, if you see, fluorine has got added. So these two definitions are very clear to us. And oxidation is addition of oxygen or addition of any electronegative element like fluorine, chlorine, bromine and iodine. Okay, now there's another aspect to this. Okay, oxidation can also be removal of hydrogen. Okay, for example, you look at this now. Okay, so here you see H2S has been oxidized to form sulfur. You see here, if you see sulfur, there is no hydrogen. So basically removal of hydrogen has taken place. So it comes under the category of oxidation reaction. Also, it can also be loss of or removal of electropositive element. You can look at this example. See, in potassium iodide, you see potassium iodide, we see it has been oxidized to iodine. So it has led to the removal of electropositive element like potassium. So these are the four cases by which we can understand what oxidation exactly is. And obviously, please understand this forms the classical definition, that is oxidation is addition of oxygen or any electronegative element or removal of hydrogen or any electropositive element. Now let's see the flip side of it. Let's talk about reduction now. Okay, so reduction is basically removal of oxygen and addition of hydrogen, and obviously the that is also applicable. You can remove oxygen or any electronegative element, okay, or you can add hydrogen or any electropositive element. So let's see some examples here. So you see two carbons means this is ethene. So I am adding hydrogen to ethene. So addition of hydrogen. So this is the case of reduction, right? So this we see ethane is getting reduced to ethene is getting reduced to ethane, right? Now the next thing is we can also add electropositive elements, right? So here in the next example, you see chlorine is getting reduced to CuCl2, right? Next example, you see mercuric oxide is getting reduced to mercury. So that is the removal of oxygen, which is another case of reduction. And last example which we have, that is FeCl3 is getting reduced to FeCl2. So these are all the examples which help us in explaining the classic definition of oxidation and reduction. But friends, this is not sufficient. We need to understand it better, and for understanding it better, we should also understand what's the exchange of electron taking place. Okay, so please remember, in oxidation, loss of electron takes place, and in reduction, gain of electron takes place. So basically there is a trick also, okay, that is oil. So oxidation is loss of electron. Okay, please remember this whenever you forget. Like we can very easily remember that oxidation is addition of oxygen, removal of hydrogen. Reduction is addition of hydrogen, removal of oxygen. Okay, so that fits into our mind, but many times we forget these 2 points also. Okay, that is, oxidation is loss of electron and increase in the charge. Second point for the reduction is it's a gain of electron and decrease in the oxidation number. So please keep these examples in your mind. It will help you a lot to distinguish between oxidation and reduction reaction, right? So we see this. Now let's understand the uh, electron transfer taking place and how we can distinguish between oxidation reduction then and there, right? So you see, we have this, I think in class 10th also we have learned about displacement reaction. So friends, that displacement reaction was nothing but the redox reaction only, and it is very important for you to understand which metal is more reactive, which metal is less reactive. So I would advise you to please thoroughly remember the reactivity series. Okay, you should know that potassium is the most reactive element here. Okay, is the most reactive element, and platinum is the least reactive element. Now why this reactivity is important? Okay, so please remember friends, like if I have a metal 1 and metal 2, and if metal 1 is more reactive than metal 2, so this metal 1 will get oxidized, right? And metal 2 will get reduced. So this, that's why we must know which metal is more reactive than the another one. Okay, so to make it very simple, I have taken an example for you, right? So I have taken two metals. Okay, this one metal is zinc and another metal is one metal is zinc and another metal is copper. So now you all know, if you see, look at the reactivity series, you see zinc is above copper. So we can say zinc is more reactive than copper. And as I just said, since zinc is more reactive than copper, zinc will be getting oxidized, okay, and copper will be getting reduced, right? Now let us understand this very clearly. Okay, let's write it down. Okay, so if you see the solution here, we have taken zinc rod. Okay, we have taken zinc rod and dipped it in copper sulfate solution, which is the aqueous solution. So obviously zinc is going to replace copper from copper sulfate solution, right? So basically this reaction is like this. I am taking zinc rod, which is solid in state. I have dipped it into copper sulfate aqueous solution, right? And as a result I get zinc sulfate plus copper, right? So now the things which we can note down here is that there will be change in color. The blue color will get converted into white or grayish color because the solution is changing from copper sulfate to zinc sulfate, right? So this change is also taking place. Now let's understand how this is a redox reaction and how we can understand oxidation and reduction in terms of exchange of electrons, right? So we have zinc here. I hope you all agree to this. We have taken zinc in copper ion solution. Okay. And obviously what is happening on the other side, we have zinc ions because in the zinc sulfate solution plus copper. Now, if you look at it, let us write the charges first. Okay, so let us write the charges. You see zinc is in the elemental solid form, so the charge will be 0, and so will be the charge of copper here. Okay, and that also will be the charge of copper. Okay, so it will be 0 0 here, and copper ions and zinc ions, they will have +2 charge. Now if you look at the increase in the oxidation number, so I see here that zinc oxidation number has increased. Okay, so this is, you can see increase in the oxidation number by 2. So as we learned in the previous slide, increase in the oxidation number or charge, okay, leads to oxidation. So this is the case of oxidation. Similarly, we see copper has got reduced because if you see the charge has gone down. Earlier it was +2, now it is 0. So this, you see, this is the decrease in the oxidation number by 2 electrons. So this is the case of reduction, right? So this is the case of reduction. So now we can say here that zinc is getting oxidized and copper is getting reduced. Okay, all of you please, this copper ion, it's getting reduced, and zinc, it is getting oxidized. Now there's one more thing which you need to remember. Okay, that is the terminology with respect to the oxidizing agent and reducing agent. Okay, so let's understand. Let me tell you, let me put it simply to you. The substance which is getting oxidized is a good reducing agent. Okay, so here zinc will be reducing agent, right? Zinc will be reducing agent. Similarly, copper is getting oxidized, copper ion is getting oxidized, so we will call it as oxidizing agent. Okay, here, so this is oxidizing agent. So please be very careful with this also. Again, I'm going to repeat it. Substance which get oxidized, they are good reducing agent, and the substance which get reduced, they are good oxidizing agent. Now why is that? See, zinc lost 2 electron and copper, that's why copper could gain electron. This copper ion, if you look at it, why it got 2 electrons? Because zinc lost it. So zinc is playing a role. Zinc is helping copper sulfate or the copper ion to get reduced. Okay, because zinc lost 2 electron, that's why copper got reduced. That's why we call zinc as the reducing agent, and copper got oxidized. Okay, copper got oxidized because zinc lost 2 electrons. Similarly, zinc could lose 2 electrons because copper was ready to accept, copper ion was ready to accept 2 electrons. Okay, so copper will be the oxidizing agent. Okay, so please just put it to put it very simply, the substance which get oxidized, which is zinc here, are known as reducing agents. Okay, and the substance which get reduced, they are known as oxidizing agents. So have this terminology clear, because many times in examinations, defense examination, they ask the oxidizing agent and reducing agent. So mainly the questions which can come from this section is, they can ask you examples of redox reaction in our daily life, that we will discuss at the end, right? They can ask you to identify the oxidizing agent of the substance or the reducing agent of the substance, right? So our terminology has to be very clear. Now let's write the equation for this. So we see here zinc is losing 2 electrons. So basically we could have written it like this: zinc is losing 2 electrons and got converted into zinc ion, right? But we don't have tradition of writing minus charge in chemistry, because we chemistry people, we are very positive, optimistic in our approach. So this -2 electron which was here, okay, it will be shifted to this side. Okay, so what is the equation of gain of electrons? How do you write zinc has loss of electron? How do you write it? You will write it like this: zinc has lost 2 electrons. So we will write it like this: zinc has lost 2 electrons. So this is the oxidation reaction. Okay, this is the oxidation reaction basically. Now let us write the reduction reaction. Okay, let us write the reduction. So we see copper being less reactive will undergo reduction. Okay, reduction in the sense it will be deposited. You see here copper is getting deposited. Okay, so yeah, the things which are getting reduced, they will also get deposited, right? So copper is gaining 2 electrons. It's very simple to write. You just have to write copper plus 2 is gaining 2 electrons. Okay, so it will get converted into copper S, right? So this is how you write the equation of reduction. And obviously when you write the overall reaction, so if you look at the overall reaction, then you will find this +2 electron, these 2 electrons will get cancelled from both the side, and the overall reaction will come out to be like this. Okay, so it will be zinc plus Cu plus 2 gives you Zn plus 2 plus copper, right? So this is how you write the overall reaction. So this was the reaction of oxidation, this was the reaction for reduction, and this is how you write the overall reaction. Okay, and please remember, zinc is the reducing agent here and copper is the oxidizing agent here, right? So I hope this is clear to you, right? Please remember, mark my words, because only simple questions like this will be asked. Okay, now the role of this reactivity series is also very important. Okay, that will tell you whether a reaction will take place, displacement reaction will take place or not. Okay, so I hope you have understood this reaction. Now at least you should know how to represent the oxidation reaction, how to represent the reduction reaction. Okay, but sometimes the examinations can confuse you also. Okay, let us see how that confusion can happen. Okay, now by now you must have understood what has happened. We had two metals, we had zinc and we had copper, and we found zinc more reactive, so zinc underwent oxidation, right? Zinc had oxidation and copper had reduction. Okay, obviously you see the change in the color. Earlier it was blue because of copper sulfate. Now displacement took place. Now this is zinc sulfate here, and deposition of copper metal can be seen here. Okay, because it has got reduced. Okay, now let's see another aspect of this. Okay, so another aspect is this, right? What if I take copper rod and dip it into the aqueous solution of zinc sulfate? Okay, what do you think? Right, so you see, as per the displacement reaction or as per the reactivity series, we see that copper is not having any capability to displace zinc because zinc is more reactive than copper. So obviously this reaction is not going to take place. So you see, there will be no change. Okay, basically what I mean to say is, if you have a thing like copper plus zinc sulfate reaction, so this reaction will not take place at all. Okay, so in competitive examination they may give you many reactions and they may jumble copper zinc and copper, and they'll ask you to identify the incorrect reaction. So this is how you have to identify the incorrect reaction in examination. Okay, and again I'm reminding for that the knowledge of reactivity series is very important. Okay, so I hope you take care of the reactivity series. Right, now let's take another example. Okay, this I have taken classical example from CBSE. Okay, so here we again, if you see, we have got two metals. One is copper and one is iron, and iron is more reactive than copper. So obviously, again, just to repeat, iron will get oxidized and copper will get reduced. Okay, so how do you write the reaction here? We write it like this. Okay, we have iron, it is dipped into copper sulfate solution. You see copper sulfate, this blue colored solution, please remember the color. Okay, we have to remember the color, this copper sulfate. Okay, copper sulfate crystals, they are blue in color, and iron sulfate crystals, they are green in color. So you see the transformation here. Okay, so because why this is green, because it has led to the formation of iron sulfate. So obviously the product is also like going to be like this, right? Plus Cu. Okay, and if you write the ionic equation of this, it will be like this: Fe plus Cu plus 2 will give you Fe plus 2 plus Cu. Right, now how to identify the substance getting oxidized and reduced? Again, you see, it's very simple. If you look at iron oxidation number is 0, right? And copper oxidation number is 0 here on the product side. Okay, so you see here iron is getting oxidized because increase in the oxidation number by 2 electrons. So this is the case of oxidation, right? Similarly, if you look at the copper, right, if we look at the copper, then we see copper has got reduced from plus 2 electrons to 0. Okay, from plus 2 electrons to 0 electrons. So this is the case of decrease in the oxidation number or the charge by 2 electrons, right? So this is the case of reduction. Now let's identify the oxidizing agent and reducing agent here. Okay, so here it is very clear in the question itself, the oxidizing agent and the reducing agents. Let's discuss about them. Right, so iron is getting oxidized, so it is a reducing agent. Similarly, copper is getting reduced, so copper ion is getting reduced, so it is an oxidizing agent. So I hope this terms and terminology remains clear to you. Obviously, how the reaction has to be written: iron has lost 2 electrons. So again we will write iron has lost 2 electrons. So we'll write it like this: Fe plus 2 plus 2 electrons. And similarly, these 2 electrons were gained by copper. Okay, so copper, so there will be deposition of copper on the iron nail, which you can see from this diagram. So copper ion will accept 2 electron and it will get reduced to copper solid. Right, so I hope that was a clear explanation. I have given you two examples. The first case which was discussed was of zinc and copper, where you find zinc underwent oxidation and copper underwent reduction reaction. Similarly, here also we saw that how iron being more reactive undergoes oxidation and copper is getting reduced here, right? So now let's come to the application. According to as I have seen in my experience, most of the reactions, they are redox reaction only. And I also told you that if reduction is taking place, then oxidation is also taking place. Just you saw in case of, like you see this case also, iron iron is losing two electrons only because copper ion is ready to accept it. Otherwise redox reaction will not happen. That's why we say the word redox. We don't say individually reduction oxidation. Okay, so you understand the significance of that also. Redox reaction means reduction and oxidation happening simultaneously in a chemical reaction. So there are many applications of this. Okay, as you can see here, the first application you see is photosynthesis, right? So this is also example of redox reaction. Then you see corrosion and rusting. Okay, so what is the difference between corrosion and rusting? Rusting is basically a special case of corrosion. When any metallic surfaces, they get attacked by substances like air, moisture, water, acid, so they get corroded. Okay, so that is corrosion. In corrosion, you have to remember two things. That's silver, right? Silver develops a black coating, okay, and copper develops a green coating because of corrosion. Iron, you already know, it is brick red. Iron develops a brick red, and iron we especially call it as rusting. So this corrosion and rusting, it is example of redox reaction. I think in one of the examinations they have asked that rusting is an example of, they wrote many things, and redox reaction was the correct answer of that. And next we have respiration. Okay, so if you see, even respiration is, right, so even respiration is an example of redox reaction, right? So just keep that also in your mind. Then next we have mm, this rotting of fruits. Okay, it can be any fruits. What is rotting? Basically when the food gets rancid, so that is also happening because of the redox reaction. Then electrolysis, that is also example of redox reaction. And we have combustion reactions, like that we have many. We have a bleaching reaction taking place, so that is also because of the redox reaction. So like that we have a number of applications of redox. These were the most important applications which you should not ignore, and there's a high chance that one of them can be repeated if they're asking you. So please be wary of all these examples, remember them properly, identify the differences between reduction, oxidation, keep them in your mind. Okay, again, oxidation is nothing but addition of oxygen, removal of hydrogen, loss of electron, and increase the oxidation number. So I hope you keep all the points in your mind and do well in your examinations. All the best everyone. Bye.